Hi everyone, and today we are going to talk about compounding n number of times beyond just once per year. So thinking back to the formula we already talked about with some growth, right? We talked about a principal value, 1 plus r to the t power is our exponential that's showing growth. Well, what's really happening here is when we have this annual growth, we have this compoundings of only one time per year. So that simplifies to just be that r to the t value, right? Well, what happens if we compound more than just one time of year? Our number of times of year might be 2, 4, 6, 12. All right, daily, monthly, we see a lot of different n values. This then, if you're compounding more than just annually, will be our formula. For instance, in number 1, we have Mary who is investing an initial amount, so our p-value of $1,473 into an account. And she has an interest rate, an annual one, of 4.37%, aka an R value of 0.034, and she's compounding biannually, aka twice a year. And what we can do is plug in a 6 then for t and actually calculate how much money that Mary has over that time. So we have 1,473 and then 1 plus 0.040437 divided by 2, and then 2, the 2 times 6, n times t power, and it's just over $1,900, ends up being her, right? 1909.18 if we round to the nearest set. 8 actually will round up so that this would become a 9. Now from here, we can also use this to work and find how much our initial investment should be. So notice on this one, we know what the balance ends up reaching. We know that we have an interest rate of 8.06 or 0.0806. And this time we are compounding bi-monthly. So every other month, aka 6 times per year. And our years, this is taking 18 years. So notice that all of this piece in parentheses, right? The 1 plus 0.0806 to the n times t is a number. Oops. Forgot to divide, though, this by the number of compoundings. Oops, divided by 6. So 1 plus 0.0806 divided by 6 to the 6 times 18 power. There we go. We get 4.2255. That's a number, right? And what we can do is divide over that value to get what our principal value is by itself, right? And again, I want to use a lot of decimal places. So I could take that amount, 5,560, divide over that value, and get about 1,300, and then we'll make the 99 rounds that 5 up to $16 would be our principal amount. All right, the next one is for you to try. You are investing money into your account at 3%, compounded 3 times per year. What is your account balance after 11 years? All right, our next example involves Mai. And what Mai is doing is she's investing a principal amount of $76.90 into a retirement account with an interest rate of 7.37%, aka 0.0737. This time it's being compounded monthly. So 12 times a year. We want to know the time it's going to take to reach our final amount of over $24,000. So this is a nice little work backwards problem because we're given the final amount we are given the initial principal value. What we are not given in this particular one is the amount of time, right? So right now, 12 times t is best we have. Now, to start this, you want to divide first, right? We're going to divide over this 7690 to get those parentheses by itself. Okay, so step one, divide over that principal value. So 24916, and we're going to divide by that principal amount of 7,690. And what's happening is on the left-hand side, we have this 3.24. On the right-hand side, though, we still have the parentheses to the t power. So inside the parentheses, I have 1 plus 0.0737 divided by 12. Oops, not 112, just 12. And this is inside of my parentheses, right? And what I want to do is get the time by itself, right? So I need to move this 12t out front using, similar to our last lesson, logarithms. Because now what's going to happen is this 12t can move out front, and I can take the log of my left-hand side and divide over the log of my right-hand side. And right now then I know that this is going to equal 12 times t. So log of the 3.24006632 divided by the log of our previous answer gives us about 192. Now reminder, this equals 12t, right? So we need to do one final step, divide by the 12, to get our final answer of just about 16 years. All right, our last example of the day is talking about Sean, and Sean is investing an initial amount of money of $3,168 into an account with a fixed interest rate, but compounded quarterly. So quarterly compoundings would happen 4 times a year. After 5 years, they give us the balance, and we want to work backwards to solve for our interest rate. So again, we want to plug in what we know. We know this time our A value. We know the principal. We know that our interest rate is what we're trying to find after compounding 4 times a year for 5 years. Now, similar to the last examples, right, we must isolate the parentheses by dividing away that coefficient part first. And once we get a value for that, the 4665 divided by, 4665, not 444, and divide that by that coefficient out front, that A value, we now have this is equal to our right-hand side. Now again, to undo something to the 20th power, we need 20th root, right? So I'm going to take the 20th root this time of my most previous answer, the 1.46, plug that in. I now have 1.019. And now this equals my piece in parentheses. So to finish solving, we're going to subtract the 1 over to get our r divided by 4 almost entirely alone, right? We have this 0.019 equals r divided by 4. And then last but not least, if we multiply both sides by 4, we'll get that r value by itself, or a final answer of, not times 44. Oops. We want times just 4. So let's redo that. Times 4 to get a final answer of r equaling 0.07699, aka if we made that into a percentage, about 7.7%. All right, thanks everyone for watching. We will work more with compounding in class.